All right. What's up, everyone? All right. So I did a poll on X, right, to see if we should do another guide or if I should just continue with the gist clone and do some live coding. It was really close. The guide won, but I feel like it was so close. I should just also start doing some live coding on the gist clone. I actually prefer doing these live streams instead of creating videos and editing them all. It's just a lot easier for me, obviously, because I'm not spending all my time editing. So today we're going to do the first section of the meta-programming guide, and we're going to work our way through that. And we're also a little bonus. Andreas wrote up a little snippet of what he wished he knew when he first started using macros. So we'll probably do. I have to figure out if I'm going to stick it in between some of our guides here, but that'll also be a stream, and it's a really good write-up. Check it out on X if you haven't. And yeah, it's cool. What is up, Chris? Good to have you, man. Yeah, so why don't we just jump right in, and I will share my screen and open Safari. And we're going to go to elixirlang.org and go over to the guides at the top here, and then down on the side menu, down to meta-programming. And today we're going to be learning about quote and unquote. And these are pretty important to understand before getting fully immersed in writing a macro. All right, I'll make this as big as I can. Maybe we can zoom in a little. All right, that looks good. Good thing you're doing this stream. I'm hesitantly writing up a big macro for a project of mine. Yeah, macros can be a little intimidating and really easy to make too big a scope and write more code than you need. So it's interesting. I did do I have a Elixir, a comprehensive introduction on indiecourses.com, and I did a macro introduction over there. If you want to learn, that goes a little deeper than what we'll be doing here, but all this stuff is good. Like, I think this guide, just learning about ASTs and all that, and quote and unquote, we're going to learn a lot today. So let's go ahead and jump in. And I feel like we'll do some examples with this stuff for sure. So I'll open up the IX shell, and yeah. Yep. And so what AST is, it's abstract syntax tree, and we're going to be diving all into that just briefly. So with that being said, let's start reading. All right, quote and unquote. This guide aims to introduce the meta programming techniques available in Elixir. The ability to represent an Elixir program by its own data structures is at the heart of meta-programming. This chapter starts by exploring those structures and the associated quote arity2 and unquote arity1 constructs, so we can take a look at macros in the next guide and finally build our own domain-specific language. And you've probably seen DSL. That is what that is. All right, so quoting. The building block of an Elixir program is a tuple with 3 elements. For example, the function call sum, and then you pass in 3 arguments, is represented internally as an atom that is calling a sum function, metadata here, and then the arguments being passed in. So you can get the representation of any expression by using quote arity2 macro. So here they're using quote do and then passing in sum, and they're getting the AST back. So let's go ahead and open up the terminal. Oh, I have it open with another project. We're just going to close that. And now I can open up my terminal, and we'll start the IEX shell. I'll make this a little bigger for us. All right. I want to see the guide because my memory is garbage. All right, there. So if we do quote do, and then we pass in the function sum with 1, 2, and 3 as arguments, we get the AST, so the abstract syntax tree representation back. And like I said, we get the Atom version. So this is calling a function called sum. Metadata will be here in a list, and then you have arguments, and that is our 1, 2, and 3 being passed in. All right, so the first element is the function name. Yeah, the second is a keyword list containing metadata, and the third is the arguments list. Operators are also represented as such tuples. So if we do quote and we do 1 plus 2, we get the same thing back. So a plus is also a function. So if we do quote do and then do 1 plus 2, the same thing gets passed. So we're calling a function called plus. And then here is the list of metadata and then our 2 arguments. And so even a map is represented as a call to our map syntax. So under the hood, our map is a macro or a function being called. So that is pretty cool. We might as well run that since we've been running everything else. So if we do, what was that? Okay, they passed in a map with a key 1. All right, so value 2. And then when we hit enter, we get our AST back. All right, so variables are represented using such triplets with the difference that the last element is an atom instead of a list. All right, so variables are represented such. All right, so the last element is an atom instead of a list. All right, so if we pass in a variable x, we get our variable back, metadata, and then our Elixir atom here instead of arguments. So when quoting more complex expressions, we can see that the code is represented in such tuples, which are often nested inside of each other in a structure resembling a tree. Many languages would call such representation an abstract syntax tree, AST. Elixir calls them quoted expressions. All right, so here we have, we're taking the sum of 1 plus 5 plus 4, but since we have this 2 plus 3 here, it's going to show up nested. So we're taking our sum, we have our metadata, and then we have our arguments here, right, inside of a list. And so our arguments are 1, but then we have another AST representation of the 2 plus 3 being added here. So this gets nested inside as one of the arguments. And then we have our last argument 4, which it makes sense. It's just, it gets a little hard to read, right? So it's good to know that this is how it works though. So if we do quote do and we do sum 1 and then we do 2 plus 3 and then 4, we get the same thing back. So we have our outer function called sum, and then our internal function that is nested using plus. So we get the same thing back. So pretty good to know. Sometimes when working with quoted expressions, it may be useful to get the textual code representation back. This can be done with using macro.toString arity1. All right, so we can get the text representation back of a function. All right, so if we do macro.toString and then we pass in a quote do and then we do sum 1, 2 plus, if I can type, plus 3, 4, and then close off those parentheses. So when we do this, we get the string representation back of our function instead of an AST. Also good to know. All right, so in general, tuples above are structured according to the following format. First, you have your atom. It can also be a tuple. So You could have another nested tuple instead of the function call. And then our metadata is always a list. And then we have our list or atom being returned as the third argument. All right, so the first element is an atom or another tuple in the same representation. I should have just read instead of explaining it before I read. The second element is the keyword list containing metadata like numbers and contexts. The third element is either a list of arguments for the function call or an atom. When this element is an atom, it means the tuple represents a variable. All right, and we saw that up here with the X example. All right. So besides the tuple defined above, there are 5 Elixir literals that, when quoted, return themselves and not a tuple. So they are atoms themselves. I think we have to run through this, right? We got to prove it. So if we say quote do and we pass in an atom, we get the atom back. All right, same thing for numbers. So if we pass in a number here, we get the number back. And then same for lists. If we pass in a list, we get our list back. And strings are the same. So if we pass in a string here, we get our string back. And then we also get tuples that are only 2 valued tuples back as the value as well. So if we make a tuple here, we have our key and value. We get a tuple back, but we are getting an AST. Oh, maybe because it thinks that these are variables. Let's try putting in values, and I think it'll be a little different. There we go. And we get the tuple back. So that makes sense because we passed in variables that return the atom of the variable and then the atom Elixir with an empty metadata list. But if you pass in a tuple with actual values, we get the exact tuple back. All right, just clearing that so we can read again. And then, so most Elixir code has a straightforward translation to its underlying quoted expression. We recommend you try out different code samples and see what the results are. For example, what does string.upcase expand to? Let's try it out. So if we do quote do, and then we say string.upcase, and then we pass in a value underscore foo, and we hit enter. All right, let's see what happened here. So like, it's hard for me to visualize some of this. Like when you start nesting too many things, it's hard to read, but let's try to break this down. So we have our outer function calling an atom dot, right? And then we have our variables being passed into a list. And so our first variable is calling our aliases behavior, or macro, I should say. And then we have, let's see. And then we have some metadata and a string being passed in as an argument. And then, let's see. And then the final is an atom being returned called upcase. Am I reading this right? See, I'm already confusing myself. All right, so in our arguments being passed in, we have a tuple as the first argument. Okay, yes. And it is taking, let's see, this list is taking 3 arguments. The alias is false, a string in a list, and then the upcase atom. And then let's see. And then we are passing an empty list and then a list of our strings that we're upcasing. So like, all right, I feel like I wish I had my pen handy. Let me think. What is the, I forgot the drawing program. 1 second, guys. I'm going to pull up my drawing program so we can draw this out. And I forgot what it's called. It is called, if you guys are listening and know the web-based drawing program I'm trying to think of, hit up those comments so I can find it quicker. Yes, thank you, Chris. All right. All right. Alexa, I don't know, Excalibur, I don't even know. But all right, yeah, this is perfect. Okay, I can draw. That's all that matters. How do I clear this? Reset canvas. Okay, I'm going to pop this out in another window. And I want to just draw this out. This, like, I don't, maybe I'm special. I don't know, but I have to do this all the time. Reading ASTs is incredibly hard for me. All right, I'm just trying to put this somewhere we can all see it. Maybe I'll just move that over. All right. That's a good spot, right? All right, so we have our string.upcase. All right, and I'm going to go from the inside out, if I can even figure that out. All right. This is a very hard example. Gonna watch the replay, man. Gotta go. All right, man. Thank you, Chris. So, all right. Dun, 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 dun. Upcase foo. All right, so we're calling a function called that, right? And then we're going to draw our little tree here. I'm going to pull up my indie course. I have a really good AST drawing in my course, and I want to just peek at it because my memory is not fantastic. All right, processes, meta-programming. Okay, introduction. All right, where is... Sorry, guys. Oh, here it is. Okay. Let's see. Quote. Okay, order of operations. All right, so order of operations. So I need to clear this out and start over. Reset canvas. All right, so the very first thing that's happening is we're calling this dot function, right? So I'm gonna, let's see, we have one function. Let's see, one function being called, and then two functions being called. I'm going to butcher this, guys, and I apologize, but we're going to try our best. All right, so if I have, let's see, the innermost function is going to be called the upcase. So we have our tuple. Let's see. We have our tuple. Let's see. It breaks my brain every time. I should have prepared for this live stream. All right, we have our dot function in a tuple. So we have our tuple with a nested tuple. as, okay, I think I'm wrapping my head around it. So we have a nested tuple with our arguments with another nested tuple. Okay. And then foo. All right, let's try to work backwards here. So we're going to, oh my gosh, I can't draw straight. We're gonna have a line. Okay, I think I can just draw a line. That's way better. All right, so if we have, we're gonna have this is going to be the upcase function. So if we put some letters here, this is upcase. All right, and this is going to have a value, or the argument being passed in is going to be the string foo. All right, and then inside of, so let's see, this is the outermost, and then order of operations here is then we have a tuple. We have a tuple calling, so we're inserting our tuple as the argument, and then we're calling the aliases macro and passing in a string. Guys, I butchered this. I kind of want to just do an easier example right now. I'm going to start off easier, so maybe it'll help my brain function. All right, so if we do, I'm going to just do quote do, and we're going to do just like a nested order of operations, like simple math, right? So if we do like in parentheses, if we do something like 4 times 3, and then we do, whoops, I have too many spaces there. And then if we do just like minus 2 plus 1. So we have a lot of things going on here, right? All right, so this is easier for my brain to handle. When we start nesting tuples as arguments, it hurts my head. So let's draw this one out. This one I can handle, because it's a lot clearer. You see that we're passing in arguments, right? And every order of operations, so we have parentheses. So our multiplication is happening first, and then everything's kind of just nested there, right? So if we go ahead and start over, reset the canvas. All right, can you guys see? Yeah, you guys can see everything. Okay, cool. This is how development goes in the real world. It's valuable to see new devs to see how experienced devs work through issues. Yeah, no, I agree. Yeah, for sure. Like, I don't know everything. I'm usually pretty good at reminding myself, but yeah, you struggle every day, especially like if you don't write a lot of macros, it's mind bending. And yeah, like right now I'm stepping back and I'm doing something easier to try to work towards the harder example, right? So yeah, I agree. Thank you for the comment. All right, so if we have our nested AST here, we're trying to figure out what's going on. And the first thing I want to do is we have 3 things happening here. We're multiplying, we're subtracting, and we're adding. So let's go ahead and like build our little tree. And the very first thing that's happening is I'm going to just build my first line here, and this is going to be our multiplication, because it's our first nested function, right? And it's taking 2 arguments, and I'm just going to suffer through using this drawing program as well, because I don't use it very often, but I feel like it's nice to use for these kind of examples. So we're going to have our multiplication function here. So This is the innermost part. So if we look over here, the innermost argument, so we have our plus, and then we have our metadata happening right here. And then we have our list of arguments. And our list of arguments is, well, one, we're subtracting, well, first, our first argument is we're multiplying 4 and 3. And then we're subtracting, where's our addition? And then we're subtracting the 2, then we're subtracting 2. So we get our multiplier, and then we're subtracting 2 from what we get back here. So 4 times 3 is 12. Then we're subtracting 2. And then what we get back there, we're adding 1 to. Okay? So see, it's already confusing, and this is a simple example. So now when we do that, we're multiplying first. Our innermost thing, we're taking 4 times 3, right? So 4 times 3, and that's going to return 12. And then we're subtracting 2 from that. So if we build our little tree, we're going to add on to our tree here. We'll do that. And then our tree continues this way because we have 3 layers essentially. And then here is where we're going to be subtracting what we got back from our multiplier. So this is our subtract function, and we're subtracting the value 2 from 4 times 3. All right, so if we look over here, we have our addition, the outermost function, but since order of operations hits, we're working our way from the inside out. So we're taking our 4 times 3, and that happens right here on this layer. And then we're subtracting 2 from our 4 times 3. Does this make sense? And this is kind of how like a tree representation can look. And then once we have our 12 minus 2, we have 10, right? Then we want to add our 1 to it, and we can put our final little tree piece here. And then this is our last thing we're doing, and we're multiplying, or we're adding, I'm sorry. And then we're doing plus, and then here we're putting in a 1. So that is the abstract syntax tree, right? Our nested value, so that is happening first, it happens here, and then it's working its way out and working its way through from the inside out. So what you're reading, like if we were to read this left to right, it's hard to read. But when you start breaking things down into like a syntax tree, which is also why like being able to just write Elixir code is amazing. And then we just put it in, it's starting to look like a gear shift. That's welcome, Brian. It actually does. It kind of, a lot of people don't know how to drive standards anymore. And it's really important to understand where all the gears are. But like reading it this way, like, so using quote is amazing because it allows us to write Elixir code, and then it returns these ASTs to us. So as you can see, like it's not very readable the more complex it gets. And I drew up a gear shift apparently. But yeah, I don't know. It's hard for me. I don't even know if I'm going to be able to draw this example with the nested tuples because it's hurting my head and I don't want to waste everyone's time too long. But so that is what an AST looks like. And we're just going to continue through and pretend I didn't make a fool of myself for like, I don't know, how long have I been going? 30 minutes. All right. So, anyways, let's play around a little more. We can also learn that using like these conditionals, we can see what they return to us. And you should draw an abstract syntax tree as a tree. It'll be easier. Top down, left to right. Top down, left to right. Top down, left to right. Top down. So left to right. So would I do like 4 times 3 at the top? Look at this. I love this. Brian's swinging in to help me out. Top down, left to right. Oh no, the top would be the 1 plus. Let's see if I can draw this. Now I'm just going to waste everyone's time. It doesn't matter. All right, so draw it as... Okay, I think I can do this, guys. Top down, left to right. So it affects... A Lisp. Okay, gotcha. All right. If I can do this. Like, let's see. Top down, left to right. All right, so we're going to have, I'm going to do this. I don't know if this is going to make sense. Will it look like a tree? And visualizing in the same hierarchy as a Lisp may be easier, but I'm probably just slowing you down at this point. I mean, probably, but that's okay. Top down, left to right. I'm trying to use my brain, which is inexistent. It doesn't matter. All right. All right. So if I did, let's see, top down, left to right. So left to right. So my plus is on the top. I'm going to start at the bottom. This shows a very basic visualization. Just wait for Keynote AST. Just wait for... Oh, here, let me... What if I Google it? Keynote AST. Nope. It doesn't let you send a URL. DM me on Twitter and I'll pull it up. We're going to sit here and wait for Brian to help me out. Keynote AST doesn't, oh, it doesn't show. It shows a very basic. Okay, well, anyways, guys, I tried and I suffered. Where's my drawing? All right, we're gonna move on, and we'll see if Brian DMs me, and I can continue making a fool of myself. All right, so let's see. We suffered through, I tried to do string.upcase, and it hurt my head. But we also learned that if true, do this, else that is the same as doing if true, do this, else that. And how does this affirmation hold with quoted expressions? All right, so quoted, let's try that. So if I do, let's see, quote do, if true, do this, else that. I'm going to have to make this a better function though. Okay, so let's see here. We have our if function being called, our metadata here, and two variables being passed in, and then a nested, let's see. So then our do else. Okay, so then we have basically our key value pairs here, right? So if it's true, it does this, else that. And let's see, that's the same as writing quote do. I think I need to do quote do. So if, is this gonna work? If true, do this, else that, and then I need that to be an atom. And if true, do, I can't have that. It's not shorthand. Okay. So if true, syntax error. Do I need a comma? If true, else. If true, undefined. Oh, I'm just quote do I need to, whoops. Guys, I just emailed you an image. Oh, sweet. All right, let's pull up my email here. How do I, okay, open with preview. All right, let's continue making a fool of myself. Oh, okay. Yeah, I think I like this better. Use an AST representation. So 1 plus 2 times 3. So order of operations. Okay. I like this a lot better. Thank you, Brian. You're a lifesaver. All right, let's try this again. I'm going to redraw things. This, sorry guys, this stream has taken a turn. All right, so let's see. Order of operations. So we're going to, let's see, if we start, so times, so 1 plus, so our multiplier is going to be at the bottom. All right. Let's clear this. Oh, no, I want to leave it. Can I just erase stuff? All right, cool. So at the top, we're going to have, can I zoom? I can shift over. All right, so at the top, we're going to have our plus, right? So the last thing. All right, and then we have our minus. Cool. And that's going to be over here. All right, and then we have our multiplier. I feel like, all right, so that would be over here. We have our multiplier. All right, I'm getting there. I'm drawing now. All right, so we have our plus that is going to be here. All right, and then so we're multiplying 4 times 3 here. I'm probably torturing you guys with how slow I draw this stuff. But this is way better, honestly. I like this. Am I doing it right, Brian? I think I am. All right, so then we have our 4 times 3. And then we're subtracting 2 from that value returned. And then we're adding what we get back here to 1. I think I did it. Yeah, that's way better. Why was I drawing it this way? I like that. All right, guys. Thank you, Brian. You are amazing, dude. All right, so look at that. Yeah, that's so much better. What am I doing over here with brackets? Yeah, I actually feel like I drew this on the wrong side. The 1 should probably have to be over here, right? Can I drag stuff? No. Well, anyways, you guys get the gist. Let's erase that. Erase that. We'll just move this over. So we'll have our top there, and then there we go. And then add our last value, which is a 1. Boom. Okay, cool. Yeah, so there we go. That was painful, and I apologize, guys. Watching me learn live. All right, cool. That's awesome. Yeah, that's way clearer than whatever square brackets I was doing over here. All right, let's move on from this embarrassing moment. All right, unquoting. Quoting is about retrieving the inner representation of some particular chunk of code. However, sometimes it may be necessary to inject some other particular chunk of code inside the representation we want to retrieve. For example, imagine you have a variable called number, which contains the number you want to inject inside of a quoted expression. All right, so this is good. This is a good example. Let's I don't know what's going on here. Let's restart our IEX shell. Clear. All right, so here is a good example. So when you use unquote, it's essentially like injecting the variable that is from like outside context into your quoted context. And this is a good example here. I'm just gonna scroll that up. So if we set a variable number outside of our quote block, and that is equal to 13, and then if we do the string representation here, and then we do quote do, and then 11 plus number, which you would expect to be a variable, it just returns the string number. And that is because it is inside of the quote block, which is inside of basically you need to pass an AST, or you need to inject a value inside of quote, so it's within the same context. So now if we did unquote here and did the same thing, it will now be 11 plus 13. And so that's not what we wanted, since the value of the number variable has not been injected and number has been quoted in the expression. In order to inject the value, the number variable unquote arity1 has to be used inside the quoted representation. And so, yeah, number 13, and then we did the unquote, and then it shows the 11 plus 13. Unquote arity1 can even be used to inject function names. All right, so we can set a variable to equal to an atom hello, and then let's see, function names. Okay, so we're unquoting function, which is just hello, and then passing in world. Let's try this. So if we have fun equals hello, and then we do macro dot to string quote do, and then if we unquote our fun, and then we're passing in. So this is essentially what we're doing is we're just unquoting an atom hello, and then the parentheses is going to be passed in with as a string, because we're just turning it to a string. Oops, what did I do? Quote do. Did I miss a undefined function macro? Oh, typo. Okay, so we're just basically turning in the hello atom into a string, and you can even notice that the colon dropped off. All right, so let's see. In some cases, it may be necessary it may be necessary to inject many values inside a list. For example, imagine if you have a list containing 1, 2, and 6, and we want to inject 3, 4, and 5 into it using unquote. Won't yield the desired result. All right, so this is a good example. So if we have our inner list here, and those values are going to be 3, 4, and 5, and then we're going to do our macro dot toString, and then quote do, and then we're going to do 1, 2, and then unquote our inner list, and there we go. And when we close this, we're going to get our list just inserted in there as another list inside of our list. So that's when unquote splicing comes in handy. And so if we do unquote splicing, then we'll get the expected result. So if we go back to this, and instead of unquote here, we're going to unquote splicing, and then it inserts our list. It appends our list with those values. So unquoting is very useful when working with macros. When writing macros, developers are able to receive code chunks and inject them inside other code chunks, which can be used to transform code to or write code that generates code during compilation. Escaping. As we saw at the beginning of this chapter, only some values are valid quoted expressions in Elixir. For example, a map is not a valid quoted expression, neither is a tuple with 4 elements. However, some values can be expressed as a quoted expression. So if we say quote and then we pass in a map with a key 1, value 2, we get a tuple back. So let's do that. So if we quote do and then pass in a map, and we have 1 and value 2 there, we get our AST back of our function map, and then we get a tuple as an argument. So in some cases, you may need to inject such values into quoted expressions. To do that, we need to first escape those values into quoted expressions with the help of macro escape. All right. So if we take a map, hello, key with the value world, we need to do macro escape to get the expected argument back. All right. So that makes sense. So we have map equals, and then our map is going to be the key hello with a value world. All right, and then we hit enter. Okay, and then when we use macro dot escape that map, my index finger wants to always hit a C before the R, apparently. So then when we use macro escape, you get our single value in the list, which is hello world. So our key and the value shows as the first argument. So macros receive quoted expressions and must return quoted expressions. However, sometimes during the execution of a macro, you may need to work with values, and making a distinction between values and quoted expressions will be required. In other words, it is important to make a distinction between a regular Elixir value, like a list, a map, a process, a reference, and so on, and a quoted expression. Some values, such as integers, atoms, and strings, have a quoted expression equal to the value itself, which we saw at the beginning. Other values, like maps, need to be explicitly converted. Finally, values like functions and references cannot be converted to a quoted expression at all. Okay, so those are good to know. When working with macros and code that generates code, check out the documentation for the macro module, which contains many functions to work with Elixir's ASTs. All right, so functions for manipulating ASTs and implementing macros. All right, we will be touching on this in another live stream. Whoop, get out of my way. All right, so in this introduction, we have laid the groundwork to finally writing our first macro. You can check that out in the next guide. So what day is it today? It's Friday. Tuesday, we're going to be hitting the macros section. So I believe this is what they just linked us to as well. Is this the same? I should open it in separate tabs. Macros. I think it's the same. Yeah. Our first macro. No, it is not. This is the module. This is the guide. So we're going to be going over the guide and writing our first macros Tuesday next week. That'll be good. This was fun, a little torturous. Thank you, Brian, for saving me. And also representing the AST this way versus whatever I was doing here. But yeah, awesome, guys. This was a lot of fun. Thank you for all the participation. It's way more fun when people chime in and help me when I am struggling. But thank you guys so much. I appreciate it, and I will see you guys in the next one.